In this lab, we're going to start to talk about how we develop code. You still don't need to write any of your own. I just want you to start to see the way code evolves as we develop it. The goal of this lab is to make a drawing of the sine function using characters from your keyboard. It's a little weird that the graph is going down where we usually draw it going left to right, but you can see that it waves between 1 and -1 cyclically, like the sine function. If you don't know what the sine function is, don't worry. All you need to know is that it takes a real number as an argument and looks like this if we give it the numbers starting at 0 and increasing. That graph is pretty complicated. One strategy to manage that complexity is to solve part of the problem without worrying about the rest of it. So let's start by writing a method that prints out just the heading at the top of the graph. You can see it down at the bottom of the screen here. The first line of the output is pretty easy. Just print out the title of the graph. The next line needs to space out the -1, 0, and 1 on the axis of the graph. Let's assume that we have a constant named max scale that tells us how many characters wide we want our graph to be. Essentially, we want to print out the -1, print out spaces for half the width, print out the 0, print out spaces for the other half of the width, and then print the 1. We can use for loops to control how many zeros we output, so you can see those parts of the code like this. Print out the -1, print out the spaces for the first half of the width, print out the 0, print out the spaces for the other half of the width, and print out the 1. The last thing we need to do is to go to the next line and print dashes for the entire width. I added 2 to max scale because we didn't account for the 0 and the 1 in the first line. That makes things line up better.
This code would be better if we were more careful about the rounding error in the max scale divided by 2. Notice that's integer division, so it's always rounding. And paid attention to the width of the numbers in the scale. We should probably clean that up, because right now our graph is 2 characters wider than it should be.
Now, we want a program that runs and uses that method to print the heading. Where do we put the code that we want the JVM to run?
In the main method. That must be declared public static void main string array args.
Exactly right. We can call our method by using its name, followed by parentheses and a semicolon. When we run this, we'll see our heading in the output. What do we say when things work?
Woohoo!
Yes. Every time something works, you must say woohoo to celebrate. Sometimes, when things aren't working, it's easy to get frustrated. If we celebrate when things do work, it helps us remember those victories. So, woohoo! In theory, the next thing we should do is output the curvy part of the graph. But that seems pretty complicated. Our second problem-solving strategy is to solve a similar but simpler problem first. So let's try to just output a line. To do this, we just have to make each line print out 5 more spaces before the asterisk. Let's make things even easier by making a method that can print one line of the graph. Since each line of the graph is just a bunch of spaces followed by an asterisk, let's make a method that takes the number of spaces to print as a parameter, and then prints that many spaces, plus 1 for the negative sign in the header, and an asterisk.
This is another example of thinking of only part of the problem at a time. We figured out how to draw one row of the output, even before we tried to draw our simpler graph.
Now that we can print one line, we just need to print a series of them, with the number of spaces in each being 1 more than it was in the previous line.
We want the number of spaces to be 0, 5, 10, and so on, up to the width of our graph.
Yep, and we can do that with a for loop. The for loop variable is h, and it starts at 0. After each pass through the loop, it gets bigger by 5, and we let the loop run while h still fits in our graph. Inside the loop, we just have to pass h into our print bar method. That will print out one line with h spaces before the asterisk. Now we've built the code for our simpler graph.
Woohoo!
The only thing left to do is to figure out how to use the sine function where we were using h. Our trouble is that the sine function has a range of -1 to 1, but we want the number of spaces to be between 0 and max scale. So let's make a method to compute the number of spaces that are appropriate for a particular sign value. Essentially, we need to take a real number between -1 and 1 and convert it to a number of spaces between 0 and max scale. Before we get to the code, imagine a few of those conversions to see where we're headed. We want a sign value of -1 to print 0 spaces because the -1 is at the left of our scale. We want a sign value of 0 to print out about half of the spaces because it should be in the middle of the line. And we want a sign value of 1 to print out max scale spaces because it's all the way to the right of our graph. Here's the code for our conversion, but don't let it overwhelm you. Let's look at it one statement at a time.
Be the machine.
Our parameter is x, and the rule is that it is a real number between the constants min point and max point, so we know that it is between -1 and 1. When I write these types of conversions, I always try to get the range to be between 0 and 1, because then I can multiply that to get a bigger range and add or subtract to move that range left or right.
This sounds a lot like what we did with random numbers. Java gave us something in the range of 0 to 1, and we multiplied and added to move it around.
Exactly. We're doing the same type of thing here. The first step is to shift things over to make our smallest value be 0. We do that by subtracting the minimum value and storing that in shifted. Now our range is from 0 to 2. In order to narrow the range to be between 0 and 1, I want to divide by the width of the range. That width is the maximum point minus the minimum point. So, if we divide shifted by the range, we now have a value that is between 0 and 1. Multiply that by max scale, and we have a range of 0 to max scale. That's what we wanted, so return that.
Details matter. Numblanks is a real number, and we're supposed to be returning an integer. The conversion from a real number to an integer might lose some information, so we have to typecast it to force that conversion. When you do the lab, you'll see that this causes a little bit of trouble that you'll have to clean up.
All that's left is to change our main method to make the graph curvy. Our main method prints out the header, but we need to change the part that was printing out that diagonal line. Java gives us a method to help. Math.sign takes an argument that is a real number and returns it the value of the sign function. Since we want our graph to start and end at 0, and I know the sign of -pi and sign of pi are 0, we're going to use a loop whose loop variable h starts at -pi and goes to +pi. For each value of h, we're going to pass it to the sign function. That call will evaluate to a real number between -1 and 1. We're going to pass that into calculate height to convert it to a number of spaces. And then we pass calculate height, which evaluates to that number of spaces it calculated, into print bar to print that line of the function.
There's some magic here. Why did you make h get bigger by 0.15?
You caught me, Zumi. I have to admit, I just played with that number until the graph looked good. That's the first part of the lab. In it, we used 2 problem-solving strategies. The first was solve a part of the problem without worrying about the whole problem.
We used that 3 times, resulting in the methods print header, print bar, and calculate height.
The second was to solve a similar but simpler problem first.
We used that when we printed out the diagonal line before we tried to make the curvy graph.
In the second part of the lab, we'll make the picture even cooler.
Cooler? Really? I'm not sure graphs of trig functions made with asterisks can even approach coolness.